Hello everyone. So my name is Julian Neves and I will be presenting to you our paper, which is applying binary decision diagram to extract concepts from triadic formal context. In our agenda, we have the introduction. So as a background, triadic concept analysis, then binary decision diagram, our approach, experimental results, and finally the conclusion and future work. So, as introduction, the goal of several research areas is the formal discovery of valid, understandable, and useful knowledge from the data. So, due to the fact that the databases are becoming larger, achieve this is getting even harder. So, one challenge is the problem of finding relationships and roles that describe the behavior of the objects contained in the dataset. One possible solution should be using formal concept analysis, FCA, which is a technique based on the mathematization of the notion of concepts and the structuring of concepts into a conceptual hierarchy. However, in some situations, it's required to describe the condition that connects the relation between the different objects and their attributes. An extension of the classical dyadic, which is the FCA, we have the TCA, Triadic Concept Analysis, which was proposed in order to deal with this situation. TCA was introduced by Lehman and Wiley, and a new dimension was added into the context, which is the condition. The notion of a triadic formal context is defined by a quadruple, where U, T, and R are set of objects, attributes, and conditions, and Y is the ternary relation between U, T, and R. In the table 1 below, object 1, attribute 2, and condition 1 belongs to Y is interpreted as the object 1 that has the attribute 2 under condition C1. In terms of our approach, we can say that one of the objects of this work was to analyze the behavior of the trias algorithm in high-dimensional triadic contexts that were generated from a syntax to SCGAZ and compare with our approach with the BDD structure. Was also proposed the representation of triadic contexts using BDDs and then performed several evaluation of the trial's behavior using the context generated by the SCG-AZ. Finally, a projection can be performed in the triadic context, as you can see on the table 1, next slide, resulting in a dyadic context, as you can see in our table 2. So as I explained previously, so in table 1 we have a triadic context, and on table 2 we have the same information but projected as a dyadic. So once we have that projected from a triadic to a dyadic, it can be represented by a BDD, converting the context to a Boolean formula used to generate the corresponding BDD. So the question here, the question number 1, has the same information that we have on table 2, but it represents through conjunctive and disjunctive operation between objects and attributes and conditions. So the symbol that has a slash represents the negation of the attribute. So we created different contexts to evaluate the algorithm with 15 attributes and 5 conditions, and then we set the density to 30% for all contexts that we tested. In the table 3 we have the results that for small, let's say, contexts. In the table 4 we have for high dimension contexts. So it's interesting because you can see here that the original trias they haven't presented any results after 14 days running, and in our approach we have results on 12 days, on 10 days running the same concept. So as a conclusion, we can say that our approach with BTD had better results without context, Also, it achieved results that the original algorithm did not achieve. And besides that, our approach is 33 times faster than the original. And finally, as a future work, we would like to implement the parallelization of the algorithm via the threads or GPU, or other important implementation would be using FPGA to have a better execution time performance. Here is our reference that we have used for this work, and I'd like to thank you all and feel free to reach me by email. Thank you and have a good event.